Let's say two friends want to go to the movies, and I don't know, movies are so expensive these days. Let's say that tickets are $12 per person, and popcorn is $4 per person. How much will it cost two people to go? Well, there are two equally valid ways of doing this. Some of you in your head might be saying, well, each person is paying $12 plus $4, and there are two of them. Or you could say it's the same as 2 tickets and 2 popcorns. This is a really basic definition of something in math called the distributive property. If I were to say this with variables, I would say A times B plus C is always equal to A times B plus A times C. If I could either say 2 of the sum of popcorn and tickets, or I could say it's the same as 2 times 12 plus 2 times 4. Problems that have variables and parentheses. If I say 3 times x plus 8, I can't do the grouping symbols part of Gremdas, but I do know that always, if there is something times a sum, it will always equal AB plus AC. In other words, in this case, this is always going to be the same as 3 times x, which is 3x, plus 3 times 8, which is 24. So let's say, I don't know, let's say A times 3 plus B. That's still going to be A times 3, as we know, we put the number first, 3A plus AB. You can also go backwards. You can say, if I say 7x plus 28, I can sort of think about, okay, well, 7 goes into both of those, so it must be out here. And that's going to be x plus 4, because 7 times x is 7x, and 7 times 4 is 28. Be careful if I say x times x plus 5. X times x is not 2x, it is x squared plus 5x. This can have implications in figuring out problems, like if I say this is x and this is x, I don't know, actually, sorry, I want to make the variable out here. Let's say 3 times 2 plus x. If I say this part of it is x, then I can say that this part is 2, and I can see that the area of this part of the rectangle is 6, and the area here is 3x. So in other words, this is an illustration of 3 times 2 plus x is equal to 6 plus 3x. You can see it in the rectangle too.